Okay, so we continue with the next subchapter, okay, so which is the speed control of the DC motor. Okay, so we have learned before how to start the DC motor by using the starter, and then now kita akan tengok how to control the speed of DC motor. Okay, before we want to design the speed control of DC motor, okay, you must know the 6 basic rules, okay, in order for us to get a very good and a very efficient of the drive system. Okay, yang pertama adalah range of speed. Okay, so depending upon the different grades and types of load. Okay, maybe you want to run the load at the low speed, at the medium speed, or at the high speed. Ataupun you nak run the motor pada wide range. Okay, maksudnya sistem you boleh run pada paling rendah speed yang dia boleh pergi and then paling tinggi. And then the second rules is smoothness of speed control. Okay, so the quality of products depends upon the smoothness of speed control. Okay, ni kalau kita guna di drive system kita guna di kilang-kilang. Okay, yang ketiga adalah economic justifiability. Okay, so method of speed control has to be efficient in terms of cost and energy. Okay, means that, so let's say after this, okay, your boss kata, okay, dia nak satu sistem untuk run this load. So first apa yang you perlu buat, you kena tahu dia punya specification. Okay, yang kemudian bila you dah tahu apa dia punya specification, for sure you akan search and then you akan select in terms of dia punya efficiency and then in terms of cost. Okay, and then yang keempat adalah stability of operation. Okay, depends upon the hardness of the speed torque characteristic. So kita dah tengok pada chapter 1 load characteristic. Okay, and then kita dah tengok motor characteristic. Kita ada speed torque, armature current speed. Okay, so you kena tahu all the characteristic and then the direction of the speed control. So macam mana? Boleh forward, reverse, left, right. So depends on number of quadrant and then permissible load at different speeds. So yang keenam ni kita kena tahu. Kita kena tahu load kita dulu. So load kita ni kita nak run in what speed? Okay. Okay, so this is the general equation for the speed. Okay, how to get this equation? Okay, you can derive this equation from the general equation. We have a EA. Okay, EA equal to VT minus IAR. Okay, and then we have a E equal to K flux omega, and then kita ada another one, torque equal to K flux IA. Okay, from these three equation, okay, you try to derive and to get these two equation where omega equal to VT over K flux minus R over K flux square torque. Torque D ni develop torque. And then omega equal to VT over K flux, okay, minus R over K flux IA. So the difference is at delta omega ni. Okay, tengok delta omega ni. For the first equation, R over K flux square TD. And then for the second equation, delta omega equal to R over K flux IA. So dia tukar dekat sini torque. Ditukar kat sini torque K flux IA. Okay. And then from this equation, okay, okay, so speed of DC motor can be controlled first by armature voltage control or terminal control here, V terminal. So we control the terminal voltage or we change the terminal voltage. So and hence the speed also change. Okay. So kat sini dia kata reducing the armature voltage VT, okay, of the motor, reduce the motor speed. Okay. Kita reduce armature voltage, speed also reduce. Okay. VT reduce, speed also reduce. And kalau kita increase the armature voltage, terminal voltage, so we also increase the speed. And then the second method is field flux control. Okay, kita control the flux. Okay, reducing the field voltage reduce the flux and motor speed increase. Betul tak? Bila kita reduce flux, okay, bila kita reduce flux, speed akan increase. So how to change the flux? By control the terminal of the field. Okay, by reduce the terminal of the field. So bila you reduce the terminal voltage pada field, bukan pada armature, reduce terminal voltage field, so kita akan reduce the flux, tapi speed kita akan increase. Okay, so the third one is armature resistance control. Okay, when a resistance is inserted in the armature circuit, means that kita connect in series. So the speed drop increases and the motor speed decreases. Okay, faham tak kat sini? So the speed drop apa dia? Okay, speed drop adalah delta omega. Okay, omega naught is no load speed. Okay, betul tak? When a resistance is inserted in the armature, kita tambah lagi resistor dekat sini. Okay, so the speed drop will increase. So at this part will increase, and then bila di sini increase, yang ni constant. Okay, and then the motor speed will decreases. Okay, so mudah kan? So kalau soalan tanya how to control the speed of DC motor, you just remember this equation. How to get this equation? You derive from these three equation. Okay, and then from this equation we know that the speed omega, speed can be controlled by controlling the terminal voltage or armature voltage control, flux control method, and armature resistance. We add another resistance series with the armature. Okay. Okay, next. Okay, base speed and field weakening. Okay. Okay, this is the base speed. Okay. Below base speed and above base speed. Okay, what is the base speed? The speed which correspond to the rated VA, rated IA and rated IF. Okay, biasanya rated ni kita dapat kalau soalan dia ada bagi. Stated here adalah the rated value. And then we have a constant torque region. Okay, here the constant torque region. So speed below the base speed. IA and IF are maintained constant to meet torque demand. Okay, VA is varied to control the speed. So power increase with speed. At this region, torque constant but power will increase. Okay, and then for the constant power region, so you look at this figure. So constant power region where speed greater than base speed at this region. Okay, and then VA is maintained at the rated value and IF is reduced to increase speed. Okay. However, the power developed by the motor, okay, power developed P equal to, okay, we have equation P equal to torque omega, okay, remains constant, known as field weakening method. Okay, so daripada sini apa yang you perlu tahu? Okay, so kalau below base speed, kalau you nak control the speed below base, okay, kita boleh control by controlling the terminal voltage or armature voltage control. Okay. Tapi kalau kita nak untuk above, you nak control speed above base speed, you pakai flux control method. Okay. Tapi kalau kita nak daripada contoh 0 to the maximum speed, we can combine both method. Okay. So, kita pergi dulu pada controlling speed by adding resistance. Okay, so this is the separately excited DC motor. Okay, you have a RA here, you have EA, you have RF. And then RA and RF, kita separate. And then at the armature circuit, we have a additional resistor to control the speed. Okay, so kita tengok sini insertion of external series resistance in the armature circuit. Okay, and then voltage across the armature terminal and shunt field are constant at the rated voltage. Okay, voltage across the armature terminal VT and shunt field, okay, constant at the rated voltage. Okay, used when the speed below the rated speed is required. And then for adding resistance method, kita guna untuk control speed below the rated speed. And no load speed is unchanged regardless of the value of resistance in the armature circuit. Apa dia no load speed ni? Okay, no load speed ni adalah yang ni, VT over K flux. Betul tak? Kita tak adjust pun VT over K flux. Kita just ubah resistor. That's why dia kata yang VT no load speed ni, VT over K flux ni unchanged. Okay, tak berubah. And then speed drop will increase. Betul? Daripada this equation, okay, speed drop, this is the speed drop will increase. Okay. And then the motor speed is reduced. Okay. And then if added resistance keeps increasing, okay, the motor speed decreases until the system operates at point 4. Okay, tengok you tambah satu RA. First RA. And then kita tambah RA plus R additional 1. Then kita tambah lagi RA plus R additional 2. And then kita tambah lagi. Bila tambah lagi, dia akan berada pada point 4. Okay, where the speed of the motor is 0. Okay, this operation known as holding condition. Means that kalau soalan tanya calculate the value of armature resistance at holding condition, means that kita tahu holding condition ni bila speed equal to 0. Okay, holding condition speed equal to 0. Okay, 0 RPM, sorry, 0 RPS, or N equal to 0 RPM. Okay, so advantage, easy and smooth speed control below normal speed. Okay, used when the speed below the rated speed is required, and in potential divider arrangement, rheostat can be used as a starter. So kalau you ingat lagi starting how to start the DC motor. So kita guna starter. So rheostat yang kita guna ni, kita boleh jadikan dia as a starter ataupun untuk control the speed. And then disadvantages, tremendous power losses, because bila more kita inject more resistance, okay, kita tahu power equal to I square R. So losses juga akan tinggi. And then large size and capacity of rheostat is required when armature current is more than field current. Sebab apa? Sebab kita nak control the IA. And then speed above rated is not possible by this method. Okay, and then dia akan bagi low efficiency lah. Sebab apa? Sebab power losses tadi tinggi. Okay, kita try this example.